As we continue our study of Chapter 2, Section 2 deals with something we call direct variation, and Section 3 deals with linear functions in slope-intercept form. Now, you did study Chapter 2, Section 2, and Chapter 3, Section 3 in Algebra 1. You did this in Chapter 5, so you should be already pretty proficient. But let's go over and review these two concepts fairly quickly. Let's talk about the vocab from 2-2. The first thing you have to understand is this concept of direct variation. Direct variation is when two things happen at the same time. As one goes up, the other thing goes up. Or as one item goes down, the other one goes down. And something important to note is that 0, 0 must be a point. Now, the equation for direct variation is y equals kx. K should look familiar to you. You're used to seeing it as m. It's like your slope if you were to graph it on a line. The constant of variation is the letter K. It's how much something changes. It's going to be a number, 1/4, 2 times 3. It's what you multiply x by to get to y. Moving on to problem 1, we need to learn how to identify if something is a direct variation, given a table. Each function determine if y varies directly with x. If so, what's the constant of variation and the function rule. To do this, now let's go ahead and remember, what does function rule mean since that's part of the question? That just means to make an equation, okay? Y varies with x, that will be a y equals kx equation. Let's check out problem A. In order to test, you are going to take each y and divide by x. And you're going to see if they reduce to the same thing. So we're going to do 2 divided by 1, because that's 2 divided by 1. And we need to see if that equals 6 divided by 3, and if that equals 8 divided by 4. You should notice that these all reduce, and they all reduce to equal 2. If that happens, if they all equal 2, that means k is 2. That's pretty easy, right? If they all reduce to 2, then k is 2. So for our equation, or our function rule, you write y equals 2x. And it's just simple like that. So we say yes, they do directly vary, and the equation is y equals 2x. Moving on to part B. Let's test. 4 over 1, 8 over 2, 11 over 3. Now I will notice that this one does reduce to 4, doesn't it? This one does reduce to 4, doesn't it? On the other hand, that one does not reduce to 4, so we just say no, it does not directly vary. Okay, so this is not a direct variation problem. We move on. Take a look at the got it. For the function over here, determine if y equals kx. In other words, if y varies directly with x. If it does, what's the function rule? So we take the first y, negative 21, divide by the x. Take the second y, negative 14, divide by the second x. And take the third y, negative 7, and divide by the third x1. This reduces to negative 7, this reduces to negative 7, and this also reduces to negative 7. Since they all reduce to negative 7, you write k equals negative 7. That's what we call the constant of variation. And then you make your function rule, y equals negative 7x. Problem 2. Identify, so we're still, take a look, we're still identifying direct variation, this time from equations. In the last problem we did it from tables. In this part we're going to do it from equations. For this function, determine whether y varies with x, directly with x. If so, what's the constant of variation? Remember, that's the letter k. Steps. Step number 1, solve the equation for y. Step number 2, if there is no constant being added or subtracted, it varies directly. Number 3, if it is direct, the constant of variation is the number, and you can only go to number 3 if you already have number 2. If it is direct, the constant of variation is the number in front of the variable x. Let's look at A. In order to solve this for y, I have to divide by 3. That will give me y equals 7 over 3x. Since there's nothing in the back being added or subtracted, you say, yes, it varies directly. Because there's nothing being added or subtraction, it takes the form y equals kx, and you write k equals 7 over 3. Part B. We're going to solve this for y. So you see we're going to divide by 7 here, here, and here. We get y equals 14 divided by 7 makes 2x, plus 7 divided by 7 makes 1. Notice how there's a plus 1 in the back. This means it does not follow, or I guess I can write no. No, it does not follow the rules for direct variation. So we stop there and there is no constant. And that is again because there's a number in the back. The problem on the bottom, or excuse me, let's try the got it and then we'll do the problem on the bottom. So we have the function rule 5x plus 3y equals 0. So we got to solve for y. The first thing you do is you move the 5x over. So you get 3y equals negative 5x. The next thing you need to do is divide each side by 3. Then you write y equals, because those 3's cancel, negative 5 over 3x. Notice there's nothing in the back, so we write yes, it varies directly, and the constant of variation is the number in front of x, negative 5 over 3. Now in the bottom here, notice where the 9 is. A lot of people get confused with this. The main idea is that it does say y equals, so it's ready to be solved. Notice there's nothing in the back. Okay, so let's just rewrite this another way. You should remember from your Algebra 1 that that is the exact same thing. Okay, so y equals x over 9 is the same thing as y equals 1 over 9x. So is anything in the back? Absolutely not. We say yes, this varies directly, and the constant of variation is 1/9. Moving on. Problem 3. Look at the title of problem 3. It says using a proportion to solve direct variation. I'm going to solve this 2 different ways, okay? I am going to solve it the first way that they ask us to, using a proportion. Some of you may like that, some of you might not. The other way I'm going to show you is using an equation. You have to pick your favorite way and stick with it. Don't get it wrong. It says suppose that y varies directly with x, and y is 9 and x is negative 15. And can you make that please say, and it looks funny on yours, can you make that say equals negative 15? I'm not sure why that happened. Make that say equals negative 15. What is y when x is 21? So what we're going to do is we're going to do this. We're going to put y over x and we're going to make a proportion. So given y is 9, I put 9 over x is negative 15, just like that. So that's y over x equals, well, let's see, they say what is y? So I'm going to do y over when x is 21. Put 21 on the bottom. Again, I did y over x. Cross multiply, okay? 9 times 21 is 189, so we write 189 equals negative 15y, divide by negative 15, and reduce, and we get y should equal negative 63 fifths. Now maybe you don't like using a proportion. Maybe you want to use an equation. Perfectly fine with me. The first thing you need to do, if you choose to use an equation, again, you do not have to use an equation. You write y equals kx, and you plug in what you know. 9 equals k times negative 15. You divide both sides by negative 15 to solve for k. And 9 divided by negative 15 is negative 3 over 5 for k. After you solve for k, you make your equation. Y equals negative 3 over 5x. Now that you have your equation, you plug in 21 for x and you'll get y right away. So you plug in 21, okay? So we'll do negative 3 divided by 5 times 21, and that'll equal 12.6, which is again the same answer we had before of negative 63 over 5. I don't care which way you like, just be able to do either of them, whichever one you want. As I do the got it, I will assume that most of you like the proportion way. Why? Because it was simpler. Which way do I like more? The equation, because it actually proves to me that you know what you're doing. But that's your choice. make sure you know what you're doing from problem 1 and problem 2 to make your equations. So let's say that you like the proportion way. Remember, you take all the y's and you put them over the x. So we're given that y is 15 and x is 3. So we do 15 over 3. They want to know what is y if x is 12. So you put y over 12. You cross multiply, and 15 times 12 is 180. And 180 will equal 3 times y, or 3y. You divide and you get y equals 60. Nothing more to it when you use a proportion. Again, if you make your equation, you should be able to do that anyway. You'll get 60 as well. Problem 4 uses direct variation to solve a problem. A salesperson's commission, it varies directly with sales. For $1,000 in sales, the commission is $85. What is the commission if the person makes $2,300 in sales? And you guys have done this. Anytime you go to like a car dealership or anywhere where the people make commission, the more they sell you, the more money they make. And that's exactly what direct variation is. If they don't sell you anything, they don't make any money. So 0, 0 is a point. Alright, so we have the commission varies with the sales. So we're going to do C over S. And that came from our sentence. So we know that there is $1,000 for the sales. So that goes on the bottom because we put sales on the bottom. The commission is 85. That goes on the top. Remember, we're doing commission over sales. That equals, and let's see, they say what is the commission, so capital C here, if this person sells $2,300. Now we're going to cross multiply 85 times 2,300. And we get 195500 equals 1,000 C. Divide by 1,000. And you will get the commission. This person is going to make $195.50 in commission. Again, the more you sell, the more you make. The got it will work the exact same way. It says the number of calories varies directly with the mass of a cheese. That's right. The more you eat, the more calories you're going to have. If you don't eat anything, you're not going to have any calories. So calories varies with mass. Okay, again, that's calories and mass, just so you don't get confused with the C. Calories over mass. 50 grams is a mass, so I'm going to put that on the bottom. 50 grams of cheese contains 200 calories. Again, we're doing calories over mass. How many calories would there be if you had a mass of 70 grams? Cross multiply. 200 times 70 is 14,000 equals 50C. Divide by 50, and the calories in 70 grams of cheese, when you divide by 50, will be 280. So let's make a nice statement here. There is 280 calories in 70 grams of cheese. Makes it nice, make your sentence. I know you actually understand it. Problem 5 is our last problem in section 2.2. And then we move on to 2.3. And it's graphing direct variation. Now, in order to graph direct variation, I will always encourage you to make an X, Y chart. Alright, there's a big difference between problem A and B. Problem A has a fraction. Problem B, no fraction. When you have a fraction, I encourage you to pick multiples of your denominator. And I'd like you to pick negatives and 0 and positives. So I'm going to pick -4, because that's a multiple of 4, 0, and +4. So let's plug that in. 3 over 4 times -4 makes -3. Now let's plug in 0. 3 over 4 times 0 makes 0. I'm just plugging in for x. 3 over 4 times 4 makes 3. And you should be able to multiply fractions by now. Now we plot those points. -4, -3. 1, 2, 3, 4, 1, 2, 3. Left 4, down 3. 0, 0, right smack dab in the middle. By the way, 0, 0 should always be a point in direct variation. 4, 3 Goes over 1, 2, 3, 4, up 1, 2, 3. Connect your points with a nice straight line. Remember that if you don't have it going through 0, 0, you did something very wrong. And that is how you graph a direct variation with a fraction. If you have a direct variation in part B without a fraction, you still make your XY chart, and you can pick whatever numbers you want, okay? I would encourage you to pick maybe like -2, -1, 0, 1, and 2. And then just plug those in. So like -2 times -2, -2 times -1, -2 times 0, -2 times 1, and -2 times 2. You just plug them in and see what values you get. Let's see, that's going to give you a +4 at the top, negative times a negative, a +2 next, because a negative times a negative, 0, a -2, and a -4. Pause the video if I'm going too fast, take a look this over. Plot your points. That's left 2, up 4. 1, 2, 1, 2, 3, 4. Left 1, up 2. 0, 0. That's right 1, down 2. And right 2, down 4. Pause the video if I plotted those too fast so you can catch up. When you're done, you connect everything through a straight line. It should go through the origin for direct variation, and you have a nice line, and that's how you graph direct variation.